SYAMIL IDHAM MUSTAFFA. Okay, today I will introduce you about our project, structure analysis project. Okay, as we know, structure design is the methodological investigation of stability, strength and rigidity of structure. The basic objective in structural analysis and design is to produce a structure capable of resisting all applied load without failure during its intended life. A structure design may be divided into three phases, which are planning, design and construction. In this project, the work involved is designation process. This phase involves a detailed consideration of alternative solution, defined in planning phase and result in the determination of most suitable proportion, dimension and detail of the structure element and connection. For construction, each alternative structure arrangement being considered. Criteria used to judge whether particular proportion will result in the desired behavior reflect accumulate knowledge based on the field and model test and practical experience. Intuition and engagement are also important to this process. The design of any structure requires many detailed calculations. Some of these are of the routine nature of Euro code or standard, such as allowable bending moment for standard size grade concrete in action. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Ahmad Adli bin Abdul Aziz. Jadi sebelum kita mula mengira beam, terlebih dahulu kita perlulah mengira beban pada slab. Hal ini kerana slab berada di atas beam. Jadi terlebih dahulu kita perlu mengira slab untuk kita mengetahui beban keseluruhan pada beam. Pertama kali ialah kita tentukan slab mana yang berada di beam yang kita pilih. Jadi bila kita dah mengetahui slab itu dan apabila kita dah mendapat keluasan, kita perlu mengetahui distribution of slab. Distribution of slab ini kita tentukan daripada Ly bahagikan dengan Lx. Jadi bila kita dah dapat nilai tersebut, kita kena tahu jika nilai tersebut lebih rendah daripada 2, ia adalah two-way slab, dan jika ia lebih daripada 2 adalah one-way slab. Jika ianya one-way slab, formulanya adalah 0.1/2 darabkan dengan GK dan darabkan dengan Lx. Jadi yang kedua ialah kita mengira pada two-way slab, iaitu formulanya ialah BVX darabkan dengan GK atau QK darabkan dengan Lx, manakala yang keduanya ialah BVY darabkan dengan GK atau QK darabkan dengan Lx. Jadi macam mana kita nak tentukan BVY dan BVX ni adalah dengan merujuk kepada table BS 8110-1 tahun 1997. Jadi apabila kita tengok dalam table tersebut, iaitu table 3.15, tapi sebelum tu kita perlu melukis dahulu. Dan apabila kita dah lukis, kita boleh tahu yang ianya bentuk triangle ataupun trapezium. Jadi sekiranya ia bentuk trapezium, jadi kita ambil nilai BVX. Kalau untuk triangle pula, kita gunakan nilai BVY. Jadi lepas kita dah dapat nilai semua itu, kita boleh masukkan dalam formula dan akan dapat nilai GK atau QK bagi beban pada slab. Jadi itu saja. Sekian, terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AZRI and I will present about the simply supported beam. Okay, for the simply supported beam, the first step we must do is to know the specification of the beam, which is we must know the characteristic of the concrete, characteristic strength of the steel bar, finishes and services, the slab thickness, variable action, permanent action, concrete density, nominal cover, and we must assume the tension bar, compression bar, and shear link. Okay, after that we must use our beam size. We must determine our beam size, which is BW, HF, HB1, B2, and L0. And we also must consider whether to use the flash beam or the rectangle beam. But for this project, we will use the flash beam. Okay, we must calculate the effective flash rate, be effective, and we must state what if be effective we must use. And after that, we will calculate the load distribution on the beam. And firstly, for load on beam, we will do the load on slab, which is we will calculate the safe weight, finishes, characteristic permanent load, and characteristic of variable. And after that, we will calculate the distribution of load from slab, which require a formula Ly over Ls. And if the result is lower than 2, it is a two-way slab, and if the result is above the 2, it is a one-way slab. And after we get the characteristic permanent load and characteristic of variable load, which is GK and QK, we will input the data into the total design load, which require a formula 1.35 GK plus 1.5 QK. Okay, if we get it right, then we will proceed to the next step, which is analysis. Okay, for the analysis, we must do the SFD and BMD for the beam. The SFD of the beam, we will get the shear force, while the BMD of the beam, we will get the bending moment. Okay, for the next step, after that we will calculate the main reinforcement, and inside it we will calculate the effective depth D, K, and Z. Okay, after that we will calculate the area of tension reinforcement. The area tension of reinforcement, we will know how many bar will be used in the design of the beam. Okay, after that we will calculate the minimum and maximum reinforcement area. And next, after that, we will count the shear reinforcement, which we will get the shear force, which is VED, is from the SFD, max shear force from the SFD. And next, we will count the concrete strut capacity. Okay, if the VED is lower than VRD max, we will must get the VED is lower than VRD max. And next, we will count the shear link. In this area we will try link, and we will get the spacing and maximum link. Okay, after that we must calculate the transverse steel in the flange. For the next is the longitudinal shear stress, and if the VED is under the 0.27 FCTK, we will not require the transverse shear steel. If it is above, the transverse shear steel is required. Okay, next we will calculate the deflection, and we will use the factor K equal to 1.0. If the span is less than 7 meter, and if the span is higher than that, we must use another value of the factor. And after that, we must calculate the LD allowable, and we must check it with the LD actual. If the LD actual is lower than allowable, then it is okay, and we can proceed to the next calculation. And for the next calculation, we must calculate the cracking. For the cracking, we must calculate for the max allowable bar spacing, and we must calculate our bar spacing too. So when we compare the both of them, we must make sure that the bar spacing is lower than the maximum allowable bar spacing. If then the result is like that, then the calculation is okay. Okay, for last part is the detailing. The detailing will show the position of the steel in the beam and the other specification in the beam.
Assalamualaikum. My name is Amin bin Ghazali, and I'm going to talk about the calculation and analysis for continuous beam. Okay, the calculation for distribution load, slab for slab and beam is the same as to calculate the simply beam. But the difference between the calculation of continuous beam and simply beam is come from the moment distribution method. We find the shear design and also moment design using a moment distribution method to calculate the shear and moment to use in the analysis. Okay, so the analysis involve flexure, shear reinforcement, deflection, and also cracking. But we need to remember that the value of K in shear reinforcement is different between simply spotted and continuous beam, which are for simply spotted we use the value of K equal to 1.0, but the value for K for continuous beam is 1.3. Okay, but from the Euro code, okay, we use the same as a simply spotted beam, which is involve fire resistant, the position of slab, and else. Okay, each student in my group have 2 span for continuous beam, so we use a moment distribution method, not a simplified method. Okay, that's all from me. Thank you.
Okay, for the conclusion, many things can be learned, and it is actually help students understand more, and any method involved with design French beam can be applied in real life. So this design work are starting with analysis process and designing enforcement and other things such as spacing, check cracking and deflection. So the purpose of analysis is to determine the stress resultants and displacements in various members of a structure under any loading, and the purpose of the design is to provide adequate member size, reinforcement, connection details, so as to enable the structure to withstand safely for the residents. And hopefully this project can be practiced for every student to understand more on designing structural things. Thank you. That's all from us. Thank you.